Welcome everybody to lesson 27 for Math 13X. Sorting data, this time about proportions. So if you just watched or recently watched lesson 26, I did something similar, but that was for means. This one, proportions. So I have this data right here, and this is the student's high school GPA, and then this is their college GPA. So we're basically going to see is there a relationship between them. And as you can see, that print is sort of small, at least it looks that way to me on the screen, so I just made a bigger copy of it right here. So the first thing to do is separate the data. So get my trusty highlighter out and start by separating them into two groups, those with less than a 3.5 in high school. So these people are going to be purple. These are the ones that are going to be purple. All right, so for those that have high school GPA less than 3.5, high school GPA less than 3.5, they're going to be purple. And I'm not even reading the rest of the question right now. I just need to know who's going to be purple. So if it's less than a 3.5, so that does not include 3.5, but anything lower than a 3.5, highlight them purple. So for example, this person, that's less than 3.5, so they're going to be highlighted purple, and I'm going to highlight them all the way across. So just look at the numbers on the left, and if there's something less than 3.5, then I highlight them all the way across. So let's see, the next one would be this one. So what I'm highlighting, I'm not even looking at these numbers on the right. I know you can't see my eyeballs, but I'm only looking at these numbers to concentrate which ones are less than 3.5. Oh, here's one. Less than 3.5. Sorry, I sometimes repeat it to myself just so I don't forget. Less than 3.5. And okay, so those are all the purple people. Then I'm going to go through and double check. Oh, I made a mistake right here. That's not less than 3.5. So I then need to unhighlight this person. I actually did that on purpose just to show you sometimes that can happen. This one is not purple. Since I don't have an eraser for that, I'll just have to say that one's not purple. Let me double check the rest. Less than 3.5. Less than 3.5. Less than 3.5. Okay. Now, when you're doing proportions, you don't have to actually type the list into the calculator. You just need to count and see how many purple ones there are. So let me count and see how many purple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this last one is not purple. So I have 10 purple. Okay, now this is how many of those are considered a success. And in here, claim the proportion of students with over a 3.2 in college. So these are the people that I'm going to be counting for the X. So out of these 10 purple ones, how many have their college GPA over 3.2? So not equal to a 3.2, but it does have to be bigger than a 3.2. So only looking at the purple ones, count them if it's bigger than a 3.2 for their college GPA. So this one, no, no, no. Bigger than a 3.2? No. Yes, here's one. And no. Bigger than 3.2? Here's one. And then remember, this one's not purple. So it turns out that there's only 2 of them whose GPA is above a 3.2. So X equals, there was 2 of them. And then P hat is just the X divided by the N. All right, now I'll repeat the process over here for the ones that are not purple. So first I need to count how many people is that are not purple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's 15 people that are not purple, or in other words, their high school GPA was at least a 3.5. Now, out of these 15 people, I then have to count how many of their college GPAs are over 3.2. So out of these, how many are over 3.2? So this one is a yes, 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 over 3.2, over 3.2, over 3.2, over 3.2, and over 3.2, and over 3.2, and over 3.2, and this person is also a not purple person, over 3.2. So I think that was all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of 15. So this would be the x divided by the n. And then 15 divided by 15 is a 1.0. 2 divided by 10 is a 0.2. All right, now test the claim that the proportion is the same for the two groups. So there's a big difference between those two, so we should be able to reject the claim. But let's go through the process. So the claim is that the proportion for group number 1, so this is already labeled as group number 1, equals the proportion for group number 2. H1 cannot have an equals, so this is going to be not equals. And then that's the part that tells me there's going to be 2 tails or 2 critical values. And then H sub O always has equals. When you're dealing with proportions, that means the critical values are going to be Z, or Z as my mom likes to say. So if you go to distribution, second distribution, and then do number 3, the inverse normal. So then it's going to ask for the area. So we'll use 95% level of confidence, which means that there is 5% left over for these 2 tails. If you cut that in half, it's 2.5%. So in decimal form, that's 0.025 and 0.025. So I can tell it it's going to be 0.025. Just leave the mean 0 and the standard deviation 1, and then you can tell it what's the left tail. And I just need to press enter. So that is negative 1.96. Because the graph is symmetric, the other side will be positive 1.96. There's the 2 critical values. Now for the test statistic. So go to stat, over to test, and then this is 2 proportions. So that's going to be number 6, the 2 proportion z-test. And I always put the n first, so the number of people, and then how many were successful. On the calculator, they switch it. So they're asking for the x first, that's 2, n is 10. And then the other group happens to be 15 and 15. And then H1 right here had the not equals, so this should say not equals, and then calculate. And the z is equal to negative 4.201. And that means that we did actually prove something here, because a negative 4.201 goes past this. So it lands way over here to the left, which means H sub O is false. The claim is also false. So the 2 groups are not the same. When it comes to proportions, the 2 groups are not the same. All right, then one last thing, and that is now make the confidence interval. So you just go to stat and then test and then look for, there it is, letter A, 1 proportion z interval. And we're doing just one group at a time. So we're just going to do this group right now. So it was 2 people out of 10. Use 95% confidence level. And it's saying that their proportion would be anywhere from negative 0.048 to 0.448. So when you're talking about percentages of people doing something, so this is basically saying it could be as high as 44.8% of the people, when they go to college, their GPA will be over 3.2. Of course, a negative doesn't really make sense at all. You can't have a negative percent of people doing something. So even though the math tells me this side really should be 0. So anywhere from 0 to 44.8% will have a GPA over 3.2. Then for the second group. So just repeat the process, stat, test, go down. And there it is, letter A, 1 proportion z interval. And then use the x is 15 and the n is 15, still with 95% confidence level. And because this is 100%, then the interval is saying that it's going to be 100%. Of course, in reality, very few things are actually 100%, but as far as the math is concerned, that's what it's telling us.